Okay, so the next thing we want to do is we want to talk about the trigonometric limits, meaning that all the limit problems we did so far, they have just x, okay? We didn't have sine x, cosine x like that. But if there is a limit that has sine x or cosine x or tangent x, cotangent x like that, how do we find out the limit of that type of function? That is the next problem I want to do. To find out the trigonometric limits, we need two formula. Okay, so these two formula actually there is a derivation to there is a way to find out this formula to prove this formula. Okay, there is a geometrical way to prove this formula, and for the second formula we use the first formula to prove the second formula. Okay, but I'm skipping that for now, and let me tell you what these formula are. Limit x tends to 0, sine x over x is always 1. So make sure that this value match with that value to get that to use this formula, okay? And similarly, limit x tends to 0, 1 minus cosine x over x is equals to 0. Again, this must match with that. By the way, these three must match, okay? So this and that must match. And similarly here, this and that must match. But for the limit, it is not a big problem because you can always get any limit you want from x. For example, if there is 5x and 5x, you can multiply both sides by 5 and then do 5x tends to 0. But we mainly focus on these two values, okay? If they match, then you can use that formula. Sine x over x, the limit x tends to 0 is 1. And 1 minus cosine x over x, limit x tends to 0 is 0. Okay, let us do these examples. So limit x tends to 0, sine x over sine 3x. You see that? So here the first formula has sine. To use this formula, you need to have sine x over x only. But there is 3. But what you can do there is you can do 1 over 3 and then do limit x tends to 0 and then sine x over x, right? What I did is I pulled that 3 outside. So you cannot pull x outside because this x has the limit x tends to 0, okay? But if there is a constant in the denominator that is not attached to any sine or cosine or anything, then you can pull that out. So what is that value is basically, this is from the formula, this is 1. So it is 1/3 times the 1, that is 1/3. You see that? So here there was 3 times x in the denominator, so I pull that outside the limit. Let us look at this example. Here there is sine 3x over x. Can we use the same technique? The answer is no. Why? Because you can pull this 3 from the sine. Why? Because that is sine and then inside the angle there is 3x. You cannot pull that out. But what we can do there is limit x tends to 0 and then what you can do is sine 3x over x times 3 over 3, right? This is basically 1. I'm multiplying by 1. It doesn't change anything, so we can write equal. But what we are doing this is, since there is 3x, I need 3x in the denominator, okay? So what I want to do next is I want to move that 3. And then this 3, I can pull that outside. 3 limit x tends to 0. And then I will do sine 3x over 3x. You see that? And if you want to, you can multiply 3. You can multiply both sides of this limit by 3 as well, because 3x goes to 3 times 0, that is basically 0. But it is just straightforward, so you don't have to do anything on the limit here. So what you can do here is limit x tends to 0, sine 3x over 3x. You see the first formula, you have the same quantity on the sine angle and the bottom, so this quantity is basically the 1, okay? This quantity is basically 1. So the final answer is 3 times 1, so this is 3. How about this one? This example. So here you have limit x tends to 0. We have sine 3x, okay? On the denominator we have 2x, but what we need 3x, right? So let us write down what you need. Similar to the previous example, what I did here is there was 2x, but I want to pull that 2 out, okay? I pull that 2 outside here, outside before the limit, okay? And then what is left is just x. And then if I multiply and divide by 3, so it will be 3 divided 3, right? 3 divided 3, and then you move that 3 to there, and then there is nothing left, right? So what you get there then equals to 1/2 limit x tends to 0 and then sine 3x over 3x. You see that? So I moved that 3 to the with x. So sine 3x over 3x. Now this 3 you can move that to the front as well. So I move that to the front as well. You see that? Now what is the answer then? So this is basically 1, right? Because sine x over x. If there is sine something, then and if there is the same thing in the denominator, then the limit is always 1. So 3/2 times 1 is just 3/2. How do you do this one then? That 3/2 is the last answer, final answer. How about this one? There is sine 3x, there is 2 sines. So we'll use that formula twice. How do I do that? This is what I want to do. I want to write the limit x tends to 0, and then what I'm trying to do is sine 3x over 3x times 3x. Similarly, sine 7x over 7x times 7x. Why did I do that? There was just sine 3x. I multiplied and divided by 3x. If you cancel out, you will get just sine 3x. But I multiply and divide. Why did I do that? Because there is 3x, I need the 3x to use this formula number 1, right? Similarly, in the denominator, there is 7x. I need the 7x in the denominator. And there is, I multiply by 7x to balance that. Okay? If you cancel that, you will get just sine 7x. Okay? So you cancel that x and x. What is left is this value will be 1, right? When you take x tends to 0, this value will be 1. So what is left is 3 over 7, just 3 over 7. Now next example, this 3 over 7 is the final answer. Next example is similar. To use the 1 minus cosine x formula, you need the same angle, the same thing as in angle in the denominator. So what I need in the denominator is 3x, but I need to multiply by 3x to balance that, right? So limit x tends to 0, I can do 1 minus cosine 3x over 3x times 3x divide by sine 5x over 5x times the 5x. You see that? Because to use the first formula, you need 5x in the denominator of sine 5x, and for the 1 minus cosine 3x, we need 3x. But you cannot just divide by 3x. You need to cancel that. We need some term to balance that. So I multiplied by 3x. If you cancel, you will get just 1 minus 3x. Similarly, if you cancel 5x, you will get just sine 5x. Okay. Now here, x divided by x is 1. Okay. So this value is 0. You see that? This value is 1, right? So basically what is happening is this value is 0, this value is 1. So what you get is 3 over 0 is 0 over 1. So that the final answer is 0 there. You understand? Okay, so next thing I want to do is this example, tangent 5x. Since our formula doesn't have tangent, just sine and cosine, you try to change that tangent into sine and cosine. So what I'm doing is limit x tends to 0, sine 5x over cosine 5x times 2x, right? That's what you do. So what we can do next is I will do limit x tends to 0. I need sine 5x over 5x times 5x, because to use the sine formula you need the same 5x in the denominator, right? And in the denominator of that it is cosine 5x times the 2x. Let's cancel that. X and x, 5x divided 2x is just 5/2, and you use the limit. Sine 5x over 5x is 1, okay? And cosine 5 times 0 is basically, this is what you do. This value is 1. This value is basically 1, okay? Now what you do next is I am plugging in the limit there. 5/2 is there. That's the number 5, because I cancel x and x. And you plug in the limit times 1 over cosine 5 times 0. Look at that. When I plug in the limit, I no more write that limit value there, lim thing, because I plugged in that already. So cosine 0, 5 times 0 is 0 degree, right? So cosine 0 is 1, so the answer is 5/2. And the final example I want to do is there is sine x, 1 minus cosine x, both of the numerator are there, but you can divide that x square into x and x. So you can do limit x tends to 0, sine x over x times limit, you can distribute the limit, no problem. The limit can be distributed anywhere in the plus, minus, product, quotient, root, anywhere, okay? x tends to 0, 1 minus cosine of x over x. So this value is 1, this value is 1, this value is 0, right? So 1 times 0 is 0. Okay, so this is how we find the trigonometric limits. Thank you guys.